All right, thank you everyone. Welcome to this talk, Chaospager, how to construct an open pager system for C3. We are a work group of passionate engineers and nerds based in Hamburg, and some of us also come from the TU Hamburg. We are a core team of 9 people, and some of us are also in emergency service organizations. We also have a number of other contributors, which we will mention in this talk. So, who are our cooperation partners? First of all, we have the CERT, and the CERT is the emergency response team at C3 events. I'm sure most of you know them. They do a really good job. And they are the main requester of this project and the contact point to the Chaos bubble. Our second cooperation partner is Delta Lima Zero Tango Uniform Hotel, and this is the Amateur Radio Association at Hamburg University of Technology. And they are providing us with equipment for our pager construction. So, how did it all start? As you can see, this is my great prototype, if we can name it like that. So, yeah, loosely coupled components with some wires. And our goal was, for the last Congress, to bring a POCSAG transmitter. And I thought, okay, what if we build our own pager? Because without a receiver, no one could use the system. So I went to my assembly group and told them, well, can you build me a CUT enclosure for this? And they were like, well, yeah, no problem. Let's build this. So this is a fully custom mainboard with ESP32 development board on the back, and yeah, a SX1278 LoRa chip, which also supports FSK, which is important for POCSAG. And as with all prototypes, we had some trouble. First of all, we had a bad reception performance. Next, we had a high RX frequency variance between modules. So even if we bought the same modules, we had a different receive frequency, so we had to calibrate the board. And this is for every pager, so this is really inconvenient if you want to roll out a lot of pagers. Also, the user interface was suboptimal. So, as with every project, we try to create our first board, and we experience some issues. For example, you know that if you have a component, you usually have a footprint. You just take the footprint, place it on your main board, and then you can put in the main board. We did this, we tried this, and this was the result. Unfortunately, there was some quite disalignment of one row. Yeah, so we bent the pins for our first prototype and made it work somehow. Also, as you can see, it's a copper board, and we have a laser. So we can structure the board using a laser, but sometimes the laser is not precise enough and leaves back some copper residue. So, as you can see here, we have 0.03 millimeter copper residue from the laser manufacturing process, and the issue is you cannot see that with your eyes. So you're just searching with a microscope under it and hope that you find it. All right, so what will be the agenda for today? First of all, I will give you an insight of the pager concept. Next, Julian will talk about the board hardware design, the custom RF board, and the production of our boards, because we built them, we manufactured them ourselves. And lastly, I will give you an overview of our POCSAG infrastructure here, and stay tuned, because there's something really interesting we will present today. And also, what can you do with our project? So, what is the concept of the pager? So we have the requirements for CERT. We made them up for the following reasons. We need an easy-to-use pager for trained and untrained emergency responders. And this is important because many of CERT angels come from different emergency rescue or emergency organizations, and they already use a pager. Most of them will use the pager here for 4 days and then not again for 1 year. And so they need an intuitive interface. They just have to pick it up and use the pager. Next, it has to be resistant towards ever-changing environments. We are here in winter at the C3, and the issue is outside we have -2 degrees Celsius, for example, but inside we have, I don't know, 20, 25. It's really warm. And the issue here is that the frequency of the receive could drift. So we have to account for that. Also, it has to be resilient against heavy abuse through the nature of unexpected events. In an emergency organization, sometimes they have to save lives. And during the life-saving process, they should not care about the pager. So the pager has to be resistant if you bang on something or something. Also, a long battery life and fast charging is essential. The best case would be if the pager would last more than the Congress, or at least the whole Congress time, and then no one would have to charge it. Or fast charging, if the CERT angel has some break, the CERT angel can just recharge it in less than half an hour, and this is also something we opted for. So we implemented 10-watt fast charging. Also, it should not generate additional work for the dispatcher. We will integrate the pager infrastructure into the existing system infrastructure of THOT, and we will cover this in a second. So what is the concept of the pager? This is our UI UX design. As you can see, 4 buttons. We have 2 soft keys and 2 hard keys. The difference is that a soft key has a variable assign function, and the hard key has a fixed assign function. So our soft keys are the buttons left and right with message and menu, and the hard keys are the buttons with up and down. So it's basically a self-explanatory interface because the manual is right on the screen. We are opting for a limited feature set for simplified operation because we know that some angels want to play with their pager, which is totally fine, but they should not be able to change, for example, the frequency or the rigs. So if the pager is configured wrongly, it will not ring, which would be really bad in an emergency situation. So we will implement only the necessary functions for them. So how does the pager firmware look like at the moment? So this is a diagram. You will receive the RF POCSAG packet, and this is received by the SX1262. The SX1262 is a radio chip, which will be covered by Julian in a second. And this radio chip receives the packet and forwards the packet to the ESP32. The ESP32 will get an interrupt and will start to decode the packet. We are using the radiolib implementation of POCSAG, which has the advantage that it will fit for many boards, but also creates overhead because of that. So this is not so energy efficient. At the moment, we are actively developing on this solution. We will implement an ATtiny microcontroller, which is way more energy efficient. So the POCSAG packet will get received and sent to the ATtiny. The ATtiny will decode the packet and filter it according to the rig. I will explain it also in a second. And the received packet will then only be forwarded to the ESP32 if it's necessary. And we need the ESP32, for example, for Wi-Fi, Bluetooth purposes. And this method is really energy efficient. All right, Julian, now you can talk about the pager design.
Yeah, thanks, Max. Now we get to the real board. I have some boards here with me. As you can see, one with housing, one without the housing. At the front, you can see some parts of the UI elements. And if you want to take a closer look, just come by to our assembly later on. And at the back, you see, for example, the ESP32. And here you get the RF board, which is custom designed with the SX1262 and also the ATtiny, which is populated here. And then basically, we just have a simple pager, which hopefully is working. Now I will talk a bit more about the RF board, because that was mostly my responsibility. There you have the, I hope you can see my pointer here, hopefully. Yeah, there's one. Yeah, there you see at the center, the big one, this is the SX1262. We chose this chip because it's quite ubiquitous. It's commonly available for quite cheaply because it's used on common nodes like the Heltec V3. Maybe you know it from Meshtastic. And after this component, there you have here some part of the filtering and antenna matching, which is needed to get a good RF performance. And here you see, here you see one spot reserved. This one is for the microcontroller. And if you just depopulate some resistors, 0-ohm resistors, then it's possible that you reconfigure with the board so that you get on the SPI MOSI-MISO pins, then UART TX RX. And so we can implement a modem on a chip, basically, for this one. So that it's also possible to take the RF board for other projects which are POCSAG related, so that maybe you can someday build your own pager with this modem on top, so that you have it quite easily. You can give it some rigs, which the pager should respond to, and then you get back the messages directly. Yeah, then the question comes, how do we assemble the boards? We opted for paste and placement of the components with solder paste. There you can see one picture of the assembly, the first part of it, where we put solder paste on all the pads using a stencil where holes are cut inside the stainless steel sheet. And then you can squeegee the solder paste over it and try to get not too much and not too little on all pads, so that also the fine-pitched pads with 0.5 millimeter spacing between the pins get soldered properly, and we don't have to do any touch-ups. And this worked out quite okay. We had, I think, 4 or 5 touch-ups. That's, I think, acceptable for us. Yeah, then after populating the solder paste on it, then we come to the point that we need to put all the components on the board. Here we can see a human pick-and-place machine, which is utilizing the quite nice tool Interactive BOM, which you can find as KiCad plugin. And if you do hand assembly, I would highly recommend that you take a look at this tool, because it makes this process quite a lot easier. And then you take this list, go to the part, put it on the board. And if you are it's too tiring for you, then the maybe proper solution in the near future is that you take a pick-and-place machine, which is hopefully soon available for us. Then this manual process will be automated fully, that you just put the board in, put the parts once in, and everything happens automatically. And then we can try to do the next prototype with the pick-and-place, hopefully. We see. For the meantime, we had some helping tools. And on the right side, you see the soldering microscope. Maybe you know it from your local hackerspace or other institution, where you can see the view of the board, put down the components. Because they are quite small, it's advisable to do it with a microscope to get a higher yield in soldering. They're roughly the size of a grain of salt or a grain of sand or something like this. But the much cooler part is on the left side. On the left side, you see a picture of the fine placer we had access to, which is quite a cool machine, because it can take the component from next to the board on an arm, and then it has an optic that you can see both the component and your board through a mirror optic, align it perfectly, then put down the arm, and that is now closely before we populated the component there, where you can lift it down precisely on the pads you want and have nearly perfect soldering results. We had to touch up 0 parts of those, so that's quite remarkable if you're in the business of soldering such parts. Yeah, and then the last step. Now we have everything on the board, and just to heat up the solder paste so that we get it to stick and to conduct electrically. That was done with a vapor phase reflow oven, because it has a quite uniform heating, and the advantage that we don't overheat parts, because in the vapor phase soldering machine, you get your boards on a tray like you can see on the picture. Then they get lowered in a bath of vapor of a medium, which condenses at 230 degrees, where we wanted to solder. And then it condenses on all the components that are not yet at the temperature. And if it gets too hot, it just evaporates and takes away the heat. So you don't get any heat spots, and can also solder weaker plastic parts or other things without any bad parts, because they stick, because plastic was molten a bit. And another pro of it is that you completely, nearly exclude the oxygen of the process and don't get the solder oxidized before it soldered the parts. And quite literally, as you can see in the oven, it's nice for bulk soldering because multiple people can populate the boards with the components. Then we shove it all in the oven, and yeah, it can solder by itself. Needs roughly quarter hour. And then the last part is, as you can see on the Mastodon post, maybe you've seen it already. Our little shark is doing the quality control and approved it, luckily, and all the boards were soldered. Then we repeated it for the second side and hopefully have a working pager, like, for example, this one, or in an enclosure like this one. If you have further questions about it, maybe we can talk also at the assembly later on. And now I will give back to Max, who will talk a bit more about the transmitter architecture.
All right, thank you, Jan. Before we clarify the question, what actually is POCSAG, I would like to ask something to you. So who of you ever heard before of amateur radio? This is basically the whole room. And who of you is licensed? Okay, still half of it? Wow, that's remarkable. Who of you brought a pager? Nearly the same number, amazing, okay. Maybe I shouldn't clarify this then. So what is POCSAG? POCSAG is a transmitter-receiver infrastructure, basically. So you have one transmitter and theoretically an infinite amount of receivers. It works using the FSK modulation, which is frequency shift keying, and it has a 4.5 kilohertz shift. It also runs on 1200 baud. And one main feature is the message filtering using the radio identification code, or in short, RIC. I mentioned this beforehand, and the RIC is a sequence of bits. So when a packet will be sent out by the transmitter, the packet will also contain this sequence of bits. When the receiver receives this packet, it will compare the sequence of bits, the RIC, against a list of sequences of bits, so a RIC list. And if there's a match, it will be shown on the pager, and if not, it will be discarded. So the filtering all happens on the receiver side. But you might ask, okay, but what happens if one transmitter is not enough? What if the range is too close? Well, it's really easy. You just take another transmitter and put it there, and now we have to orchestrate this. So to orchestrate something like this, we are using TDMA, so time division multiple access. This is a time slot method, and using DAPNET, they implemented a method with 16 time slots. So one time slot for each transmitter, and you can configure them how you want. Or you can also put multiple time slots for the transmitter. And as I mentioned before, the receiver will not only ignore a packet which is not relevant for it because the RIC does not match, but it will also ignore reception duplicates, which can happen because every transmitter in this group will transmit the same package. So, how does the hardware for this look like? Our main goal was to build 3 transmitters. I don't know what happened here in Chaos, but we have 7, plus 2, which are not in the picture. Yeah, we brought all of them, we used 3. So, the main radio of this is a Motorola GM1200. We chose that because it's already licensed, it's a commercial radio. We know that also the RF transmission is clean on there. And it can feature, for example, 10 watt output power. Then the radio is controlled by a Raspberry Pi 3. And the Raspberry Pi 3 controls the audio, the push to talk, which I will not explain, you all know what it is, but explain it for it. And okay, the pager transmitter is basically ready to use. So you just take the box, plug in 12 volts in the back with power pole, plug in network, and then it will automatically work if your master is up. And we put it into a 19-inch enclosure. And for our Raspberry Pi, we created a custom header. And this is the custom header. It features level conversion for audio signals. It has a PTT for transmission, so it enables the transmission part of the radio. The receive part is not needed, by the way. And it also acts as a power distributor for the radio and the Pi. You all might know that the Raspberry Pi can only accept 5 volts, so there's a voltage conversion happening. We also included reverse polarity protection and fuses. So the advantage of this board is it provides a minimized external wiring harness. And if you want to build your own transmitter, you can download the schemes of this and build it yourself because we made it open source. Now the question, how should the CERT interact with our system? CERT has its own open source dispatcher system called THOT, not with D, but with T. And I don't want to explain too much because they did a fantastic talk at the last Congress, so you should definitely watch it. But what makes sense to explain is that there are the emergency responders represented in that software. So when you put out an alarm, it will invoke an API call to our POCSAG system, and then the pager transmitters will transmit the call. So what is our current solution for this? At the moment, we have this wonderful interface here. We cannot use DAPNET Core 1.0 because it has an incompatible license. It's for amateur radio use only. And when we are live, when we have the real system, it's not only amateur radio, it's commercial radio systems. So also different frequencies. So for Easter egg 22, this year, we needed a quick and dirty solution. This is the quick and dirty solution. Yeah, it's based on Flask, Bootstrap, and accesses the web sockets on the pager transmitter. And we thought this is good enough for testing. So you all might ask, okay, what is the final solution for us? What do we do to orchestrate the system? And in the beginning, I said this could be something interesting because when I stumbled along, I met Johannes. And Johannes told me, I know Johannes for some time now, and he told me he's working on something. But I should be silent about this until this moment, so I was. And I know that you're watching, Johannes, so hello. Let me present you DAPNET Core 2.0 Alpha. DAPNET Core 2.0 Alpha is based on a modern architecture, so it's based on a microservice architecture. Yeah, it has a quite modern tech stack compared to the old one, Python, CouchDB, and RabbitMQ. An example, for example, the CouchDB can scale horizontally really easily because you can put them all into one, I forgot the term for this, but you can basically couple them and they will synchronize under each other. And from the outside, the communication happens via RabbitMQ, which is an MQTT broker. It features a REST API, so this is really helpful for THOT. And the interesting part for us also is the MIT license, because that way we can also use it for commercial services, and this is the final goal for the CERT, at least. What he wanted me also to point out, he conducted a benchmark. So he had a 1-core Xeon something. I think it has more than 3 gigahertz per core. And he assigned it 2 gigabytes of RAM, and he is doing 2,000 messages per second with 200 transmitters, no problem. So it is really capable. But at the moment, we are not doing commercial radio service. We are doing amateur radio service. So you might ask, what is the experiment? We prepared 3 research questions. And so the research questions are the POCSAG transmitters able to cover the Congress area? The second one is, can DAPNET 2.0 Alpha Core orchestrate a small-sized transmitter network? This is essentially important because we are basically doing the first alpha test with real transmitters here at Congress. So yeah, we will see what the result will be there. And also, what is the alignment of the reception sensitivity between values measured in the lab and the real world? Because we had some really great results with the RF board, but we have to validate if they are wrong, if they are correct or not. Yes. So, what can you do at our assembly? First of all, let's talk about the project. Many of you already came up to us and talked to us, and this is really nice. You could try out, if available, our new pager prototype. So basically our nice board. And you can register yourself in our paper call book. Also, you can send out your own POCSAG message. Of course, licensed amateur radio operators have no problem, they can just send it out. But if you're not licensed, you can still come and we will find a solution. If you brought your own hardware, which many did, you can receive it on their usual amateur radio frequency. And we would like to ask you to hand in reception reports. They were really helpful for our last development step. And yeah, we would really appreciate if we could receive them. So we could map the building for reception strength and blind spots. Also, we implemented a test payload. We could, of course, use dev/urandom and send it out via the transmitter network, but this wouldn't make sense. So we opted for talk announcements. This is equal data, basically, in a sense for experiments. And yeah, Christian was kind enough to write the software. It's PHP 8 based. And yeah, you have different talk groups. Those are not all of our talk groups. Sorry, not talk groups, but rigs. These are not all of our rigs. If you want to get the whole list, just visit our website, for example, on this QR code. And there you can program the correct rigs in. So, what will be the outlook? We of course, need to improve some things. For example, miniaturization of the main board. This was also one of the main factors why we developed our own RF board. And the advantage is that we just can use the RF part on the main board, and then we have a much more miniaturized design. So we can build a smaller pager. Also, as we mentioned, the increase of energy efficiency with the AT-Tiny. This is an active development, and we expect it to be done soon. And yeah, also we are working on a Wi-Fi back channel for alarm responses. If an emergency responder receives the call, he can give an alarm response via back channel, via Wi-Fi, and then the CERT knows that they received the response. For new features, of course, DAPNET 2.0, the integration of THOT, and endpoint analytics, which is really helpful for us for development. Also, we want to make this field deployable, so we will build boxes where we can put in the 19-inch cases. For example, flight cases was the plan. Yeah. So, to wrap up, we will give another talk at Norddeutscher Funktag 2026. Norddeutscher Funktag 2026 will take place at the Hamburg University of Technology, so in the city, and it's on Saturday. And there we will present our experimental results from this congress. There are also other assemblies, talks, and a flea market for amateur radio. So if you have questions or if you're interested, you can just go to this link, Delta Lima 0 Tango Uniform Hotel.de/Funktag, and there you will find everything. We also distribute some stickers here, I think. And lastly, if you're interested in our project after the congress, follow us on Mastodon. We will post regular updates on it, and you can follow us there, as many already do. So, NOC. Thank you for the NOC for your support. The NOC was kind enough to provide us with a VLAN and their tech support, so we are able to route the system. We are able to distribute our system through the whole building here. Thank you.
Please, Max, Julian, thank you for your talk. Please queue up for the Q&A. And until that, I have a question regarding KiCad plugins. Are there more? Were you using more than just the BOM plugin? And yes, which ones?
Yeah, you have a quite active open source community around the KiCad plugins. The interactive BOM is the one I use the most. but you have for all kinds of RF stuff or doing some custom PCB coils or something like this. Just take a look in the plugin repository and KiCad, and you probably find something that you say, that happened to me 2 weeks ago, or something like this.
Great, thank you. And then I remember everyone, just one question per person, please. Let's start with microphone 1.
So, thanks for the talk. You mentioned that you were doing, or you were planning on going to some kind of commercial frequency in the end, so something like an emergency service frequency, or what's the plan there?
No, we will use a commercial frequency. So in German, it's called Betriebsfunkdienst, and they have appropriate frequencies on the same band. So it's 70 centimeters, but a little higher in frequency, and we will use that frequencies.
Great, thank you. Then a Signal Angel question, please.
The internet wants to know, wouldn't it make more sense to have swappable batteries rather than fast charging?
Yes, we've also discussed that, and it could be that this could be helpful. The issue is that this is really, that this is a challenge on its own to design durable, swappable batteries.
Yeah, and the idea of this prototype here was that it's rapid prototyping, and we have something for Congress where we can still do some development on it, and we have some pin headers where we can attach some stuff. So a swappable battery maybe later.
Great, thank you. Then microphone 2, please.
Thank you for the talk. So it was hard to judge from the pictures. Is there any haptic or alarm or something on it, or do you rely for your phone to notify you?
Yes, good point. We will install a vibration motor and a beeper, so you have an acoustic feedback and also a haptic feedback.
Maybe the technical part, maybe turn off the microphones shortly so I can demonstrate. Is tight? So that would it be. And also vibration motor.
Great, thank you. Then let's move on with microphone 3.
Yeah, thank you for the great talk. My question is that for SX1262, did you encounter any EMC loss while testing, because the RF loss and the range that you can cover, it depends upon how much layer of PCBs you are having, and there are other things you have to consider when you make this kind of an RF product. Did you have to consider anything, or you just took some sample and just went with it?
Yeah, that's a good question. We ordered it a bit around the Semtech reference design. I mean, as an engineer probably know, you take the first look at the reference design and base your own design about this one. And then we had some problems that some components weren't at the ports in the assortment we had, but mostly it worked out. And we also have a 4-layer board so that we can do a great ground plane under all the RF parts. So one ground plane in the whole RF board is completely ground.
Okay, yeah, thank you.
Great, thank you. Let's move on to microphone number 4.
Hey, thanks for the talk. Why did you opt for this dual MCU configuration with the ATtiny and the ESP32? And why did you not maybe use an ATmega for that? Because it seems like that would have been sufficient to handle the UI, maybe?
Yeah, that was mainly because we wanted to put something small on this small board in a short time that had a simple programming interface, because this one has just 3 pins, power, ground, and 1 programming pin. This was easy to implement and easy to program by registers, so we can utilize all deep sleep and something like this interrupts. So we opted for something, the lowest hanging fruit, basically, and we have to reevaluate if we take something bigger, STM32, bigger ATmega or something like this.
Thanks.
Great, thanks. Then another question from the internet, please.
The internet wants to know about your numbers, about range, reception, packet loss testing, if you did some sort of RF overview measurements already.
So the question was if we already conducted experiments here, or how should I take this question?
Some RF testing. The question is about how much RF testing have you done?
Sorry, I cannot.
The question was, I'm strongly interested on the numbers about range, reception, packet loss testing, whether they already did some RF overview measurements.
Okay. Yeah, we are on it. So this is basically what the Congress is for here.
Great, thank you. Then microphone number 2, please.
Hi, I had a question about the security of the system. Since it's a completely open, unencrypted protocol, POCSAG, everybody can listen to everything and everybody can spoof everything. Is there any thoughts about that?
Yes, we will not transmit personalized data, patient data, any critical data using that system. It's an addition to DECT, for example. So the CERT angels, I think, use DECT, for example, at the moment. And it's also another addition, so it beeps, and then they don't have to monitor anything. They know, OK, just call dispatch, and dispatch will tell them.
It's not like people can send a message to another pager and are not aware that their message is not secure.
I mean, if you want
to be aware.
Yes. If you want to spoof the system, it's of course possible, but when we are on commercial frequencies, that shouldn't be a problem.
Great, thank you. Then I would like to move on to microphone number 1.
Thank you for the talk. Last year was at your assembly, and we tried to get a POCSAG app on the Flipper Zero to work, and it didn't work. Do you know if it works now?
Do you know that?
We had 2 people already with Flipper Zero, and they didn't get any receptions, unfortunately.
All right, thanks. Then microphone number 3, please.
Yes, thank you for the talk, also from my side. One small question, maybe I missed that in your talk, but which kind of accumulator are you using to fulfill your requirements?
Accumulator? Do you mean the orchestration or
the battery?
No, the battery.
Yeah. That's a lithium-ion battery pouch cell, so that's a bit flat. But you can take a look at the assembly, how it's constructed internally if you want.
All right, thank you. Thank you another time for your talk. Where can we find you after this presentation? Where is your assembly, actually?
Our assembly is right besides the CERT. We have a large antenna, or we have 2 large antennas which you can look for. Please don't come everything at the same time after the talk, but yeah, we'll be there the whole Congress.
Great, thank you. Then please, another round of applause for Max and Julian.